We had used a Gantt chart for our project to record our activity from week 1 to week 15. For our objective, first is to achieve an equally weighted dough. Second, to save cost, labor and time to produce. Third, to design and develop an easy-to-use and affordable machine. Our target market is small and medium enterprise, which is in food industry.
For the exploded view, we use SolidWorks feature to complete the task. The working principle of the dough divider machine is, firstly, the dough will be mixed in the hopper. The motor will turn the spiral-shaped mixer to mix the dough. After the dough is well mixed, with the help of workers, the workers will open the trap door and push some of the dough into the machine. Then, the piston will suck the dough into the cutter. Now, the cutter will rotate to the volumetric chamber. At the volumetric chamber, the piston will push the dough that is inside the cutter into the volumetric chamber. The volume of dough can be controlled by changing the height of the spindle by twisting it in like a screw. After the dough is pushed, the dough will hit the wick and the wick will hit the touch sensor locating at the end of the spindle rod. The sensor indicates that the dough reaches the desired volume. Then, the cutter now will be rotated to its original place. By the mass of the wick, the dough that has been cutted into desired volume will be pushed out to be dispensed and the wick will be remain at the volumetric chamber. The cycle now will continue until desired amount of dough is reached.
Next, we move to the product simulation. In this product, it has been divided into several parts, of which the main part is mixer, T-part and body frame. Simulation will be carried on these parts using SolidWorks Simulation Software version 2020. During the simulation process, load will be applied to the component. There are two types of analysis that will be carried out, which is static analysis and buckling analysis. Static analysis consists of three types of analysis, which is stress von Mises analysis, displacement analysis, and strain analysis. The load that will be applied for each part, which is mixer, is 294.3 Newton. For T part, load is 41.59 Newton, and for body, load is 937.93 Newton. These are the static analysis for stress von Mises for mixer, T-part and body frame. These are the displacement analysis for mixer, T-part and body frame. This is the analysis for strain analysis for mixer, T-part and body frame. The next analysis is buckling load. These are the outcome of the analysis, which is buckling load analysis towards T-part, body and mixer.
Hello, I'm going to explain explain about data analysis based on the questionnaire. So they have a three part on the questionnaire, which is part A about demographic of company, part B first is problem statement, and the second one is the problem had been faced by SME, and last but not least the part C, customer requirement for the design. So our focus will be on part C, as the analysis is to fulfill the requirement of customer satisfaction. Now I'm going to explain about the requirement for design of door divider. So customers strongly agree on a design that is stable and strongly agree with the portable, but averagely they agree on the compact. They are strongly agree with the design that have stability and strongly agree about the portable design. Second graph is about the requirement for performance of the door divider. So most of the customer wanted the performance with a high strength and fast performance for their machine. For the second last part of the requirement for safety of door divider, most of the customer, which is they are strongly agree with the easy to handle, but at the same time they agree onto the easy to store. And last but not least, most of them agree with the user friendly for the safety of door divider. For the last graph, requirement for marketable of door divider, most of the customer want the inexpensive, which is cheap. Second one is they wanted easy to do maintenance, they are agree about it. And last but not least, most of the customer are agree on the low energy usage.
I'll discuss about costing in manufacturing door dividing machine. In cost evaluation, there have few costs that we have to consider about before launching our product. The cost that I'll discuss is for manufacturing one complete machine. Firstly is the direct material cost. Direct material cost is the cost for all raw material and component used. In our project, these are the list of raw material that we include in our direct material cost, and the total is RM19,498.21. Next is direct labor cost. Direct labor cost is the wages for individuals who get involved physically. For our case, we only calculate for workers who do the fabricating of operation, and the total is 1,200. After assuming time taken to fabricate our product, total direct labor cost is 350 per unit. After that is overhead cost. Overhead cost is referring to the cost of expenses. Overhead cost for our project include electric bills, water bills, and transportation is 630 ringgit. Total overhead cost is 183 ringgit and 75 cent per unit after considering time taken to fabricate. Next is development cost. This is the cost for conducting surveys and spreading flyers, with total for this cost is 20 ringgit. After that is overall cost. Overall cost is the summarized cost from direct material to the development cost. The overall cost is 20,050 ringgit and 96 cents. Lastly is the total cost. Total cost is the value of overall cost sum up with the markup price 45% from the overall cost. The total cost is 28,072 ringgit and 74 cents. Finally, for costing of our product with 30 kg weight and material made up from aluminium and plastic, the price for sale is 28,073 ringgit.